For this lesson, we're going to be looking at solving equations with variables on both sides. So if we take a look at this equation, the first thing we notice that is different from this equation compared to the ones that we have solved previously is that if we continue to look at both sides of the equal sign, right, like if I draw a line here, I still have an x or a variable on both sides. So my recommendation to you is to always get rid of the smaller variable first. That way you have less of a chance to end up having to use negative numbers. Sometimes it cannot be avoided. However, if you get rid of the smaller variable first, you are more than likely not going to have to use a negative number. So if we look to the left-hand side, our variable is 12x. If we look at the right-hand side, our variable is 7x. 7 is smaller than 12, so 7x is what we want to get rid of first. So the equation is plus 7x. So again, just like with every other equation, we have to do the opposite or the inverse to start isolating the variables. So I need to do the opposite of plus 7x, which then is minus 7x. So on both sides of the equation, I want to subtract 7x. On this left-hand side, if I have 12x, 12x minus 7x gives me 5x. I didn't do anything with a minus 28, so it stays there. And then I didn't do anything with the negative 63, so it stays there. And then 7x minus 7x gives me 0. And then I also still have the equal sign in the middle. So now I have a regular two-step equation to solve. So I have to start to isolate my variable now by getting rid of the number that is further away from it but still on the same side of the equal sign. That would be the 28. So the opposite of minus 28 is plus 28. Minus 28 plus 28, they cancel each other out because that's 0. I'm left with 5x, my equal sign. And then now we have to be careful here because we're adding with a negative number. So remember, when you add and one number is positive and the other number is negative, it's like subtraction. So we can say that that problem is 63 minus 28. If I do that, I get 8 from 3, I can't, so it has to become a 13. Then this 5 is what the 6 becomes. So 13 minus 8 is 5, and then 5 minus 3, or minus 2, I'm sorry, is 3. So I'm left with 5x equals 35. But the only other thing we have to consider is what we have more of. Do we have more negatives or do we have more positives? The 63 was negative, the 28 was positive. So the 35 would be negative because we have more negatives. Then my last step would be to take both sides and divide them by the 5 because right now the x is being multiplied by the 5. So dividing by 5 is the opposite of multiplying by 5. These two 5s then cancel each other out. I'm left with x. I have my equal sign. And then negative divided by a positive, first of all, is a negative. And then 35 divided by 5 is 7. So my solution is x is equal to negative 7. So here we have, again, the same steps of what we did to solve that equation, but we have the steps justified. So this, again, goes a little bit beyond what we have done in the past. So the first step we did was we subtracted 7x from both sides. Because we did it from both sides, that still is a property of equality. And because we subtracted, the property is the subtraction property of equality still, but we did not do it to isolate the variable because we had two variables. When you solve an equation, you only want one. So the reason we did it is to eliminate or get rid of a variable term. So my justification for that first step is the subtraction property of equality to eliminate a variable term. The next thing we did was we added 28 to both sides. Since we did it again to both sides, our justification is the addition property of equality. This time, though, we only have one variable, so our purpose or our goal, or why we did it, is to begin to isolate the variable. The next thing we did was we divided both sides by 5. Dividing both sides by 5 gives me the division property of equality to isolate the variable, and then the x equals negative 7 is our solution. When we have equations with variables on both sides, there are two special things that can happen. The first special thing occurs in the following example. If you look at the equation that it gives you, it says 3x plus 4 equals 3x plus 4. Two things you should note here. First thing is that both sides of my equation, both the left and the right side, are exactly the same, 3x plus 4 and 3x plus 4. The other thing you should note is that my recommendation to you was to get rid of the smaller variable first. So if we look at the variables, on the left-hand side I have 3x, and on the right-hand side I have 3x. There is no smaller variable because they're both identically the same. So they're both being added to the 4. So to get rid of or to move the variable, we would have to do the opposite, which is subtracting 4. When you subtracting 3x. So 3x minus 3x gives me 0. They cancel out. And then on this side, 3x minus 3x also gives me 0, so they cancel out. So the only things I'm left with are 4's on both sides. So I get the statement 4 equals 4. 4 equals 4 is a true statement. So because the variable is gone and you get a true statement, what that means is that you would have infinitely many solutions. And then here where it says write an equation that would have infinitely many solutions, again, just like up top, you could notice that both sides of the equations are exactly the same. So anything I write, I could say x divided by 3 minus 2 is equal to x divided by 3 minus 2. It doesn't matter what you put there as long as both sides are identically the same. The other special thing that could happen is like this. Okay, I have 3x plus 4 on the left-hand side of my equation, and then 3x minus 6. Notice that my variable terms are still the same, however, the numbers or the constant terms are what is different. So, again, my recommendation to you is to get rid of the smallest variable. Since we don't have one, they're both the same, then let's just get rid of the one that comes first. So the one that comes first says 3x plus. So adding 3x to something, the opposite is subtracting 3x. So I want to subtract 3x from both sides. So 3x minus 3x gives me 0. They cancel out. And then the same thing happens over here. 3x minus 3x also gives me 0. So they cancel each other out. This time I'm left with the 4 on the left and a negative 6 on the right. The statement we have now, because the variables again are gone, is that 4 is equal to negative 6. That is not true. That is false. So because we get a false statement, that means this equation has no solution. Now, if you were to write an equation that would have no solution, again, look at what we noticed up top. We noticed that the variable terms were the same, but the constant term was what was different. So if I were to write an equation that would have no solution, I could say 5x plus 7 is equal to 5x. Notice again, my variables are the same, but the constant terms are different. So I could say plus 6. Because these constant terms are different, that would end up being nothing or no number that I could put in for x and make that equation be true.